Hello everybody, it's Mrs. Montague here, and in this video we are going to go over Unit 4, Lesson 14, which is our Conditionals Practice alternative lesson. So Unit 4 actually gives us two different conditionals practice lessons. The Lesson 14 one that we're going to cover in this video is the original conditionals practice from a couple years ago, and then a few years ago they updated the conditionals practice lesson to the existing current one, which is lesson 7, but we still have the original one available down here as the alternative, which is actually the one that I prefer. I feel like this gives you much more practice using conditionals than the other lesson does. But we're just going to go over both of them in these videos. So this first one on the conditionals practice is going to be this lesson 14 alternative. So let's jump into it here with bubble number 1. All right, in bubble 1, we have the instruction to read the code and predict what will appear in the console. Then we are going to run the code and watch how each question is answered. And then finally, we are going to add code to answer the last two questions. So we're going to need to create Boolean expressions to answer these questions. So we have a question asking, is 3 less than 5 for question 1? So that is converted into a Boolean expression that looks like 3 less than symbol 5. Okay, so when we print this to the console, ideally, right, these are going to be Boolean expressions that evaluate to true or false. So we're either going to get true or false as our output for the console logs. So is 3 less than 5? We know 3 is less than 5, so we should get an output of true for question 1. For question 2, is 3 equal to 5? So we have our equal to operator here in line 5. So 3 equal to 5 is how that is converted into a Boolean expression. We know 3 is not equal to 5, so this one is going to evaluate to false for question 2. All right, question 3 we have is 3 greater than 3. All right, converting that into the Boolean expression, we get 3, the greater than symbol, 3. So 3 is greater than 3. Again, we know 3 is not greater than 3. So this should hopefully give us a false output in the console. And then question 4 is 2 times 2 greater than or equal to 5. All right, so we're converting this again into a Boolean expression. 2 times 2, notice how that is in parentheses because this section needs to be evaluated first before it's compared to 5 on the other side of our Boolean operator here in the middle. All right, so 2 times 2 is going to be evaluated, which we know is equal to 4. All right, so it ends up being 4 is greater than or equal to 5 is what's being evaluated here. 4 is not greater than or equal to 5, so this one should also give us an output of false. So if we are correct in our predictions here, we should get true, false, false, false. So let's go ahead and run it and see what happens. It's going to show us down here in our debug console the answers to these questions. I'm going to speed it up just a little bit here. All right, so let's go ahead and run. Okay, is 3 less than 5? Yes, it is. That's true. Is 3 equal to 5? No, it isn't. That's false. Is 3 greater than 3? No, that is false. And is 2 times 2 greater than or equal to 5? Also false. All right, and then we have question 5 and 6 that we will need to put in our code to answer. So the great thing about Boolean expressions when we are using them in programs like this, the program is going to automatically evaluate these expressions for us, right? So it's going to determine if it's true or false without us having to actually do any math as long as our expression is correct in here. Okay, so we know that we got the correct answer to all of these, right? We can just read through them and see that. So let's go ahead and get our code added for question 5 and question 6. All right. So we're going to need console logs to output our answers. So I'm going to go ahead and drag in my first console log for question 5. All right, so question 5 is asking, is 10 less than or equal to 10? All right, so we need to put in a Boolean expression in here to determine this. And we know we need the less than or equal to symbol because that is what the question is asking. So we need to find that symbol, less than or equal operator. And we are going to put that here in our message section. And then we need to put in our numbers. So it's asking if 10, so the number 10, is less than or equal to the number 10. All right, so we have 10 on either side of that less than or equal to symbol. All right, that one should evaluate to true because 10 is less than or equal to 10, right? It's not less than it, but it is equal to it. So that should evaluate to true when we run this. But let's go ahead and get question 6 answered before we check it. All right, so question 6, we know we're going to need another console log to answer this question, so we'll drag that in. All right, so question 6 is 10 minus 3 greater than 3 times 3. All right, so we're going to have two math expressions on either side of our Boolean operator that are going to determine, that are going to be evaluated before the full Boolean expression itself is evaluated. All right, so let's go ahead and see. So it's 10 minus 3 greater than. All right, so we need the greater than symbol, right, which is this one right here. So we have greater than, right? We know that we need that because of the middle of the question is asking if it's greater than. All right, so on the left side of this greater than symbol, it is telling us 10 minus 3. All right, so is 10 minus 3 greater than 3 times 3? So we need, in parentheses, I'm going to put 10 minus 3. All right, I'm putting this in parentheses because this needs to be evaluated before it determines if this side is greater than the other side. Okay, so 10 minus 3 is going to be our first side. All right, then on the other side, we need to see if that is greater than 3 times 3. All right, so again, we're going to be doing a math expression with multiplication here. I'm going to put it in parentheses. So this has to be 3 times 3 on this side, and your times symbol is the little asterisk on the keyboard. Shift 8 gets you that little asterisk symbol. You can also go ahead and drag in these operators from your math toolbox over here. I usually just type it in because I find that to be easier, but whatever works for you. You can drag it in either way. All right, so then we have 10 minus 3 is greater than 3 times 3. All right, so both sides are going to evaluate first before the full expression is evaluated. So 10 minus 3, we should hopefully know is 7. All right, and then so we get 7 on this side, and is that greater than 3 times 3? 3 times 3 is 9. So 7 greater than 9 is false. So we should get a false output for this. So when we run this program now, we should get for question 5 true, and then for question 6 a false. So let's go ahead and reset it and run it again to see what we get. All right, we already checked the first 4. So we're just looking for question 5, confirmation that 10 is less than or equal to 10. That's true. And then is 10 minus 3 greater than 3 times 3? That is false. All right, so we know it has evaluated those expressions correctly, and we are getting the correct outputs. All right, so if you have any questions, make sure you check in. Otherwise, we are going to move on to bubble number 2. All right, here in bubble 2, we have a instruction that says read the code to predict how questions 1 and 2 will be answered. Then we're going to run the code and watch the console to check our predictions. And then we're going to need to add code to answer questions again. All right, so this one's a little bit different. We're still doing essentially the same thing, but it's different because in lines 1 and 2, we have a variable for score and a variable for lives being created. All right, so we saw this with our lemon squeeze game, right? We had a variable for score and a variable for lives in there, and we could call those variables to get the values plugged into a Boolean expression. All right, so that's what they're doing here in question 1 and question 2. So question 1 says, is score plus lives less than 13? All right, so they have converted that into a Boolean expression down here. So we get score plus lives, and that needs to be less than 13, okay? So when we do this, when we run this program, it is going to plug in the values currently being stored in the score and lives variable to evaluate this expression. So we know score is equal to 10, so this really is going to become 10, plus lives, which is equal to 3, so this is going to become 3, so it ends up at 10 plus 3, and less than 13. All right, so 10 plus 3 we know is going to be 13. 13 is not less than 13, so this expression should evaluate to false when we run this. All right, question 2 we have is lives times 3 equal to score. All right, so we have our equal Boolean operator here in the middle, equal to. All right, and then on the left side, we have lives times 3. All right, so they're putting in that lives variable. Notice, again, when we call our variables, we do not put them in quotation marks because they are storing a value for us, so we don't need quotation marks around them. All right, so we're calling our lives variable, which is 3. So we get 3 times 3 is equal to score, and we know score is 10, so this side is going to be 10. So it ends up being 3 times 3 equal to 10. 3 times 3 is going to be evaluated, which is 9, and 9 is not equal to 10, so this should evaluate to false. All right, so let's go ahead before we answer questions 3 and 4. We're going to go ahead and run it to check our answers. And I am, again, going to just speed this up a little bit here. All right, so our variables were created. Okay, we get the output of question 1 as false. All right, score plus lives less than 13. All right, 10 plus 3 is 13. That's not less than 13. We get false. All right, lives times 3, which is 3 times 3 is 9, is equal to score, which is 10. All right, that also evaluates to false. So let's go ahead and get question 3 and question 4 answered. All right, and we're going to answer these in the same way. We're going to have calls to these variables to plug in these values. All right, so we know we need a console log pulled in to answer the question. Right now I'm just going to go ahead and pull in 2 console logs, one right below question 3 and one right below question 4. So those are just in there and ready for us. All right, so question 3 is asking if score minus lives is greater than 5. All right, so we need greater than for our symbol. So let's go ahead, find our greater than operator and pull that in here. Okay, on this side, on the left side of the expression, we are going to have is score minus lives. All right, so we need to take the value of score. Again, no quotation marks around this. Score minus lives. So again, we're calling these variables to get the values from them. So we're taking the value of score minus the value of lives. And is that greater than 5? All right, so we just put in the number 5 over there. Okay, so this should evaluate score minus lives, which is 10 minus 3. So 10 minus 3 we should get is 7. All right, and then is that greater than 5? Yes, 7 is greater than 5. So ideally, question 3 should evaluate to true. All right, so let's go ahead and answer question 4 before we check that. All right, so if question 4 is score times 2 greater than or equal to lives times 10. All right, so we need score times 2 greater than or equal to. All right, so we need our greater than or equal to symbol in the middle, right? That's what it's asking for here. So we find our greater than or equal to operator, and we can pull that in. All right, this time I'll go ahead and pull in the other math expressions so you can see how that works for either side. All right, so the left side, we need score times 2. So we're doing some multiplication, so we can find that multiply operator and pull that in over here on the left side of our greater than or equal to symbol. All right, so we're taking score, the value being stored in score, multiplied by 2. All right, so score times 2. Then on the other side of that Boolean operator for greater than or equal to, we are looking for lives times 10. So again, we're doing math. For multiplication, we're going to bring in our multiply operator. And this time we're taking the value stored in our lives variable times 10. All right, so score times 2, our score is 10, so this is really 10 times 2, is greater than or equal to lives, which is 3, times 10. All right, so 3 times 10. So 10 times 2 is going to be equal to 20, and lives times 10, which is 3 times 10 is going to be equal to 30. So our expression ends up being 20 is greater than or equal to 30. All right, that is not true, so this should evaluate to false. All right, so let's see if we get those outputs correct for question 3 and question 4. And I'm going to speed this up just a little bit more. All right, so question 3, we can see down here in the debug console, score minus lives greater than 5, 7 is greater than 5, we got true. All right, and then we get score times 2 greater than or equal to lives times 10, which we know is 20 greater than or equal to 30, and that got us the result false. All right, so it looks like everything has evaluated correctly for these expressions, and we can go ahead and move on to bubble number 3. All right, in bubble 3, it says to read the code for questions 1 through 3 and predict the answers. Then we are going to run the code to check if those predictions were correct, and then we will need to put in our Boolean expressions using our logical operators and, or, and not for questions 4 and 5. All right, so this is another one that's using variable values that we are plugging into these Boolean expressions. So we have our fruit servings is equal to 3, our vegetable servings is equal to 5, and our grain servings is equal to 4. All right, so question 1 is asking, am I eating more than 3 fruit servings and more than 5 vegetable servings? All right, so they have it in all caps, the word and, all right, because and is the logical operator that we need to put in here. All right, so we need the double ampersands or the and symbol to compare both sides of this. All right, so am I eating more than 3 fruit servings? Okay, so fruit servings has to be more than 3. And vegetable servings have to be more than 5. All right, so fruit servings is greater than 3, right? We need more fruit servings than 3. And vegetable servings need to be greater than 5. Okay, so we can compare what we have. Fruit servings is set to a value of 3. So 3 is greater than 3 is going to evaluate to false. We technically don't even need to check the other side of this because with an and operator, you will remember that the both sides of the equation need to be true in order for it to evaluate to true, right? So if fruit servings is not greater than 3, that's going to evaluate to false, and it just automatically makes this whole thing false. It just so happens that vegetable servings is set to 5, which is also not greater than 5. So this side is also going to be false. So this is like a truly false expression here, right? Neither of these things are true, so we're going to get a false. All right. So question 2, am I eating 4 or fewer grain servings and 4 or fewer fruit servings? Okay, so grain servings has to be less than or equal to 4. And again, they have it in all caps here, the word and. So this is an and operator that we are using in between these two expressions. Okay, our double ampersands. All right, and fruit servings has to be less than or equal to 4 as well. Okay, so grain servings less than or equal to 4 and fruit servings less than or equal to 4. Our grain servings is 4. That's less than or equal to 4, so that side is going to evaluate to true. All right, so since we have one side that's true, we need to check and see if the other side is true. If this side is false, it's going to be false for the whole thing. But if it's true, it is going to give us the correct output. So fruit servings is set to 3. And then fruit servings less than or equal to 4. 3 is less than or equal to 4, so that is also going to be true. So we end up with a true output because both sides of this and expression are true. All right, question 3 is asking, am I eating exactly 5 grain servings or any amount besides 2 fruit servings? All right, so this time our word in capitals is or. All right, so we know we're going to need to do the straight slashes, the 2 straight slashes for or in between, which they have here. Okay. So on the left side, we need to eat exactly 5 grain servings. So grain servings needs to be equal to 5. Okay, we know grain servings is 4. All right, so grain servings is not equal to 5. This side is going to evaluate to false. Now for the or, right, this does not just end it, right? The whole thing's not going to be false just because one side is false. Either one side or the other side has to be true in order for us to get a true. Both sides would need to be false to get a false response. Sorry for the bell. All right, so grain servings is not equal to 5. We know that's false, but fruit servings is not equal to 2. So it's any amount besides 2 fruit servings. All right, fruit servings is 3. So we know 3 is not equal to 2. This side of the statement evaluates to true. So since one side is true and the other side is false, this statement is still going to overall evaluate to true because only one side needs to be true for an or statement to evaluate to true. All right, so let's go ahead. We have question 4 and 5. Those are the ones we're going to need to add the code to answer. But let's go ahead and just run it with questions 1, 2, and 3 in so we can see if our predictions were correct. All right, so I'm going to speed our slider up just a little bit. Okay, when we run it in our console, all right, we get question 1 is false, right? Because we knew that 3 was not greater than 3 and 5 was not greater than 5. All right, so that's false. If we're eating 4 or fewer grain servings and 4 or fewer fruit servings was true, right? Because it was less than for both of those. All right, and then I am eating exactly 5 grain servings or any amount besides 2 fruit servings, right? That's true because we were eating any amount besides 2 fruit servings, even though we weren't eating exactly 5 grain servings. Doesn't matter, one of those statements was true. All right, so we get that true value. So now let's go ahead and get our code in for question 4 and question 5. All right, so question 4 is asking, am I eating exactly 3 grain servings or exactly 3 fruit servings? So the first thing we're going to do is drag in our console.log to answer this question. All right, so we're going to put 1 below question 4. I'm also just going to go ahead and drag in my console.log for question 5, which we'll get to here in a second. All right, and then we can go back to our math toolbox. So we have, am I eating exactly 3 grain servings or exactly 3 fruit servings? All right, so again, or is the word that is in capitals here, so we know that we need an or Boolean operator in between our two statements. All right, so we're dragging in that vertical slash symbol, all right, for the or. All right, so on the left side, it's saying, am I eating exactly 3 grain servings? Okay, so if it's exactly 3, it needs to be equal to 3. All right, so we're going to pull in our equality operator over here on the left side. Excuse me. And we are going to put in here that grain servings. All right, that's that variable value. All right, so grain servings is equal to 4. Grain servings has to be equal to 3. Okay, am I eating exactly 3 grain servings? Okay, so grain servings equal to 3. We know since grain servings is 4, that's going to evaluate to false, but since this is an or statement, let's see what happens with our other side. So we need to also potentially be eating exactly 3 fruit servings. So again, we're going to bring in our equality operator over here on the right side, and this time fruit servings needs to be equal to 3, okay? And if we grow up and see our value stored in fruit servings, it is 3, all right? And we know 3 is equal to 3. So this side of the Boolean expression is going to evaluate to true. Since this is an or and we have one side that's true, this whole entire expression is going to evaluate to true, or it should when we run this and check it, all right? But before we do that, let's answer question 5. All right, question 5. Am I eating 5 or fewer vegetable servings and any amount besides 5 grain servings? All right, so this time we know that our Boolean operator is and. That is the word that is all capitalized in the middle here. Okay, so we're joining these together with an and operator. All right, so we drag that double ampersand in. All right, on the left side of the equation, we're looking for, am I eating 5 or fewer vegetable servings? All right, so to translate that into our math expression, vegetable servings or veg servings needs to be less than or equal to 5, right? 5 or fewer. Okay, so veg servings is less than or equal to 5. You can also drag that block in. This time I just typed it in, but when I click out of it, it's going to automatically convert it into the correct block. All right, so 5 or fewer vegetable servings. And then over on the other side, we have any amount besides 5 grain servings. So basically, grain servings cannot be 5. It can be anything else, but not 5. All right, so our not equal, our inequality operator is the exclamation mark with the equal sign, right? Not equal to is what that means. Okay, so our grain servings needs to be not equal to 5. All right, so our vegetable servings when we look up is 5. Okay, so that is 5 is less than or equal to 5, right? That's going to evaluate to true because 5 is less than or equal to 5. It's equal to it. All right, and then grain servings is set to a value of 4. Okay, 4 is not equal to 5, so this side should also evaluate to true. Since this is an and both sides of the statement are true, this is going to overall evaluate to true, or hopefully when we run it, all right, because it is an and. Both sides need to be true in order for us to get the true value. So let's go ahead and run this again and see what happens for our last 2 questions in this sequence. All right, so we predicted that question 4 would be a true, right? We have exactly 3 grain servings or exactly 3 fruit servings. We did have exactly 3 fruit servings, so it is true because one or the other needed to be true to get the true outcome. All right, and then question 5, am I eating 5 or fewer vegetable servings? Yes, I am. 5 is equal to 5. And any amount besides 5 grain servings, 4 is not equal to 5. So both of those are true, and we get the true outcome. All right, so it looks like we have done this successfully. We are getting the right outputs, and we can go ahead and finish and move on to bubble number 4. All right, bubble 4. It says build an app where the star changes color based on the number of clicks. So we are going to add clicks to the watch window on the bottom right. Okay, so we can add variables down here in our watchers panel, right, by just typing in the name of the variable. And you can either press enter on your keyboard, or you can click on the little blue plus. All right, and it will add that variable value to your watchers. So basically what this means is when I have a watcher down here, right, anytime the value of clicks changes, it is going to update the value stored in my clicks watcher down here. So I can see that value changing as the program is running. Right now it says clicks is undefined because I am not running this program yet. All right, but we have on line 2, our variable clicks is equal to 0. So as soon as I run this program, well, it's going to say not available because we have some errors here. All right, so let's go ahead and fix our issues before we get into what we're actually doing here. Okay, so it says add clicks to the watch window in the bottom right. We did that. Add Boolean expression to the if statement that checks if there are 5 or more clicks. Okay, so we have this error right now because we don't have a Boolean expression in this conditional statement. So I can't switch to block mode because we have errors, and we need to fix those errors before we can switch it to blocks and view it that way. All right, so let's go ahead and add our Boolean expression here. So it needs to be in between the parentheses after our if statement, okay, right here on line 11. Okay, so in these parentheses, I need to check and see if there are 5 or more clicks. So when we put that into a Boolean expression, right, clicks, our value stored in clicks, needs to be greater than or equal to 5, right? 5 or more clicks is greater than or equal to. So we want 5 or more clicks. Okay, and then it should change our star to red. All right, so now that we've got that Boolean expression in there, we can see that the errors went away because we now have completed this conditional statement, and I can switch it to block mode. So here in block mode, all right, we see again on line 2, we have variable clicks has initially been set to a value of 0. All right, when we click on the star, it is going to add 1 to our clicks value. All right, again, this is our variable counter pattern. It's just adding 1 each time we click. Okay, and then it's going to set text for our number of clicks to our clicks value. So that's the number of clicks down here. All right, our num clicks is being set to the clicks value. Then we have the conditional statement with our Boolean expression. So if clicks is greater than or equal to 5, our star icon color is going to change to red, right? If clicks is not greater than or equal to 5, it's going to ignore this line of code on line 12 and just skip it entirely, okay? So it should stay black until we have 5 or more clicks. All right, so this time, now that we have fixed the errors in the code, when I run the program, we can see our watcher down here in the panel has changed the initial value of clicks to 0 because that is what it is set to on line 2. All right, so clicks is equal to 0, and then clicks is equal to 0, and we have the number of clicks displaying as 0 on the screen. All right, so I'm going to click on the star. When I click one time, we see our value down here at the bottom of the screen changes to 1, and our watcher value changes to 1. All right, so it's keeping track of my clicks in multiple places here. All right, we change it to 2 clicks, 3 clicks, 4 clicks. All right, now when I click on this a 5th time, right, that's going to make our clicks value be 5. So then our expression here is going to be evaluated. If clicks is greater than or equal to 5, it should change the icon to red, right? So 5 is greater than or equal to 5. Our star should change to red on my 5th click. And it does, right? So any click after 5 is going to keep the star red, right? Because any number after 5 is going to be greater than or equal to 5. All right, so our star stays red no matter how many clicks that we do. All right, and then it's just that easy, right? We have our Boolean expression has been completed in our conditional statement, and it is working as expected. All right, so we're going to see this star a few more times as we move on to bubble number 5. All right, bubble 5, it says that we want to add code so that the star changes colors based on the number of clicks, right? We're doing the same thing, but this time we're going to have a little bit more in-depth color changing here, okay? So first we're going to run the code to see how it works, all right? So if I have, this time they say if clicks is less than 5, okay? So they've changed this to clicks less than 5 for our conditional statement here. When our clicks is at 0, when we initially start it, it's not changing the star color yet because it hasn't registered the on event of a star click to trigger all of the code inside this. And our conditional statement is here inside of the on event, so it's not going to check this condition until we click at least one time, all right, because that's going to trigger this on event to run. Okay, so when we click the first time, right, 1 is less than 5, so it has changed the property of the star to red, okay? Any number of clicks beyond that is going to keep the star red, so even when we get up here, right, to 14 clicks, 14 is not less than 5, but we've already changed the icon color to red, so it's not going to like revert back to a prior version of the program and change it back to black, right? Anytime we've clicked, it's set to red, it's going to stay red now until we change something about this conditional statement, okay? So hopefully that made sense. All right. But we want to change the if statement, or the conditional here, to a statement that is an if-else by clicking on the plus, right? Remember, we have this little plus on the bottom bar of our conditional, so we can add tiers, what I call tiers, to our conditional statement. All right, and then we need to add code in the else section to make the star orange. All right, so if we scroll down a little bit more in the instructions, it gives us instructions on what we're supposed to do. Okay, so if our clicks is 0, it's going to be black, right, which it was. If our clicks are 1 through 4, it's going to change to red, which it did. And then if our clicks are 5 or greater, it is going to change to orange. Okay? So right now, it's keeping the star red because there's nothing else telling it to change to any other color. All right? But now that we have this else line, we can put in a set property. to change the star icon color to orange. All right, and you can just type in the color name. You can also do the drop down and select an RGB color or a hex color. So however you want to do it for this particular bubble and the next bubble, whenever bubbles we're working on this star, I find it easier to just type in the name of the color. So whatever, however you want to do it. All right, so I'm just typing in orange. So this time when I run the program, all right, 0 clicks is black. All right, we know that. When we click once, it's going to be red because 1 is less than 5. When we click twice, 2 is less than 5, so it stays red. When we click third time, it's 3 is less than 5. That's still true, so our icon is red. On our fourth click, 4 is less than 5, so our star stays red. But now this time when I click for the 5th time, 5 is not less than 5. Okay, so this statement is going to evaluate to false. So it is not going to set the icon color to red. Instead, it's going to skip that line and do whatever is in our else value, right? So this wasn't true, so it's checking the next tier of our conditional statement. Okay, so when I click for the 5th time, right, the star color changes to orange because this is no longer evaluating to true on our first tier, so it skips over it to do the second tier of this conditional statement. Okay, so now anytime after 5, our star is going to stay orange. Okay, again, if there's any questions on this one, let me know, speak up. All right, otherwise we are going to move on to bubble number 6. All right, so this time we're still dealing with our star. We're still changing the color of our star, okay? But let's go ahead and run it and see what happens first because we've got a little bit more intense of a conditional statement here. All right, so on our 0 click, it's still black. Okay, when I click it one time, it changes to red. The first tier of our conditional is still saying if clicks is less than 5, it's setting our icon color to red. Okay, so as soon as I get to my 5th click, it's going to change the icon color to orange, okay, because it skipped the first row of this conditional because it has evaluated to false, okay. But now we have this second tier that says if clicks is less than 10, our icon color is going to be orange. All right, so 5 is less than 10, so we have an orange icon. All right, when I do my 6th, 7th, 8th, and 9th click, it's going to stay orange because 6, 7, 8, and 9 are all less than 10. But when I get to my 10th click, 10 is not less than 10. All right, so this tier is going to evaluate to false. It's going to skip over that, and it will default to our 3rd tier here, which is to set the icon color to pink. So when I click on this for the 10th time, my icon changes to a pink star, right? Because both of the tiers above this last one have evaluated to false. Therefore, we're defaulting to the last tier value, which is a pink star. All right, so we're going to have to add some more tiers onto this conditional, some more sections onto it, however you want to call them. And we are going to look at the table below to make sure that it is working how it should. All right, so this time we have quite an intense table that we're looking at here, and I'm going to expand it just a little bit so we can see what's happening. Okay, so we have clicks 0 sets the star to black, 1 through 4 sets the star to red, 5 through 9 sets the star to orange. So these first 3 sections of this table are actually working correctly already. All right, but then our 10th click, we changed to pink. But here it says 10 through 14 is supposed to be yellow. 5 through 19 is supposed to be green. 20 through 24 is supposed to be blue. 25 through 29 is supposed to be violet. And 30 plus is supposed to be pink. All right, so we need a tier that's going to change the star to yellow, 1 to green, 1 to blue, and 1 to violet before we get to pink. So we need to add at least 4 more tiers onto this conditional statement. All right, so again, we are clicking on the plus button at the bottom of the conditional to add 1, 2, 3, 4 more tiers on here. All right, I'm going to drag my pink set property all the way down to the bottom tier, right? Because that's still, that's not what I wanted to do. I didn't want to get rid of it. We just want to drag it down to here. All right, because we still want to set the star to pink at the very end, right? Once we get to 30 plus clicks. So we know that's going to be the very last color that we're changing to. So that needs to be at the very end of the conditional. All right, so we're going to look up here for the rest of our tiers. All right, so we know clicks less than 5 was working to get the right red value. Clicks less than 10 was working to get the right orange value. So now we need clicks less than 15 to get our yellow value, right? Because anything 10 through 14 should change our star to yellow. So if it's less than 15, that means it's 14, right? It goes up to 14. And we are going to pull in our set property here to change our star icon color again. Whoops, not hidden. Icon color to yellow. All right, so then that should get our icon changing once we hit 10 clicks, and then once we get to 14, at this point it would default to pink because we don't have anything in the next tiers, but we need to add that. All right, so green, we want clicks 15 through 19. All right, so we're just going up by 5 for each of these statements, right? Each of these Boolean expressions. So clicks this time needs to be less than 20. Okay. And of course, you can make these expressions however you want it to be, right? It doesn't have to be clicks less than 20. It could be clicks is less than or equal to 19, right? And it would still work that way. So however you want to do it, it's easiest, I think, to just do the intervals of 5 here, okay? So we're going to change our star icon color in that case to green. All right, we're just going through the full rainbow here. All right, then if we have clicks less than, this time 25, because 20 through 24, all right? So clicks less than 25, we want to change our star icon color again, this time to blue. All right, and then our last tier that we have to get our information in here for is to change it to violet. So that's 25 to 29 clicks. So this time, again, we're just moving with our intervals of 5 here. So clicks less than 30, right? We are going to set the property of the star icon color to violet. I am personally going to put in purple because I think their violet color is weird. So I'm just going to put in purple because I like it better. All right. And then that should do it. You can also just copy and paste your set property line to each one of these tiers if that makes it easier for you. And then you just change the colors instead of having to do the full set property line over and over again. However you want to do it, as long as it's working right. All right, so now we have all tiers of this. All right, so once we get to 30 clicks, right, 30 is not less than 30, so it is going to change it to pink like it should, hopefully. All right, so let's go ahead and reset it and run it. Okay, 0 clicks is black. 1, 2, 3, and 4 clicks is red. All right, 5, 6, 7, 8, and 9 clicks are orange. Now my 10th click should change to yellow, which it does. Awesome. So 10, 11, 12, 13, and 14 are all yellow. My 15th click, right? 15 is not less than 15, so it's going to go to the next condition to check, which is clicks less than 20. That should change to green because that is a true statement. All right, so 15, 16, 17, 18, and 19 is green. Once I hit 20, we should change to blue. So 20, 21, 22, 23, and 24 stay blue. And then 25 through 29 should be violet or purple. All right, I love that rich purple color. So much better than the violet. All right, so 25, 26, 27, 28, and 29 stays purple. And then when we get to 30 clicks, right, 30 is not less than 30. So it's going to skip to that very last tier of the conditional statement and change our star to pink for any click beyond 30. All right, so we just have a star going through the full rainbow colors and changing colors based on the number of clicks. All right, so we just have a long conditional statement here. right? But you can see how this is most specific case first, okay? Because 1 through 4 clicks is a lot less of a range than anything above 30 clicks, right? Because 30 through 1,587,000, right? All of those are going to be pink. So that's the least specific condition down here. All right, most specific is first. Okay, let's go ahead and finish this bubble number 6, and we'll move on to bubble 7. All right, so this one we have the same star, same program, but it's telling us to debug the code because the star never turns orange. Okay, so we need to figure out why our star is not turning orange. Okay, so it says to switch it to turtle mode. So we're going to go not quite full turtle, but we're going to go a little bit less. Okay, and kind of watch the highlighted lines of code to see why the star never changes to orange. Okay, so we're going to run it. Initially, it's black, right, which is what it should be. All right, we're going to click 1 time. Okay, and then it changes to red, how it should. Okay, when we click twice, it's still checking that first condition and changing it to red. Okay, still on the first tier. When I click for the 5th time, this is when we should change to orange. Okay, so the 5th time, we actually ended up with a yellow star. Okay, so if we read this conditional, all right, we can see that we have our most specific case first of clicks less than 5. But then when we get to the second tier of the conditional where we should be turning it to orange, it turns to yellow instead because we have clicks less than 15. Okay, so when I click for the 5th time, 5 is less than 15, so the second tier of the conditional is evaluating to true and changing the star to yellow. Right, but then if we look at the statement right below that, it's clicks less than 10, right? And that's what's changing my star to orange. All right, 5 is less than 10, but since it's also less than 15, and less than 15 was checked first, excuse me, it's not even going to check whether or not the star is less clicks than 10, because it skipped right over that by checking if it was less than 15. All right, because less than 10 is more specific than less than 15. All right, so this is just an error of the most specific case not being first. All right, so all we need to do here to fix this is switch the yellow tier and the orange tier. All right, so my clicks less than 10 needs to be up here above clicks less than 15. Okay, so we've changed it there. I don't know why it adds an extra set of parentheses, but it's not going to bother anything. All right, so clicks less than 10, then we just need to flip-flop yellow to orange. If it will let me highlight the word, that would be great. All right, orange. And then down here, we change this one to yellow. All right, so we've just flip-flopped the order. If I could spell yellow. All right, we've just flip-flopped the order of the clicks less than 10 to set it to orange, and the clicks less than 15 to set it to yellow. All right, so now we are still increasing by our intervals of 5, right, as we can see as we go down the conditional statement. All right, so this time when we reset it and run it, it should do the same thing that it did last time. I'm going to speed it up a little bit this time. All right, and it should just run us through the full rainbow. All right, so we have 1 click, and 2 clicks changes us to red. All right, when we continue clicking, when we get to 5 clicks this time, it changes us to orange, right? Because it is picking up the proper tier of the conditional first that is more specific than the yellow. All right, so when we click, continue clicking, at this point, once we get to 10, all right, 10 is not less than 10. So it is going to go to the correct yellow tier now and change the star to yellow. All right, so if we keep clicking through this, let me just speed it all the way up because it gets annoying. All right, if we keep clicking through this, it is going to go through the rest of the colors with no problem because we have set it to the right order this time. All right, did you see how unfortunate that violet color looks let's see, when we get to 25 clicks, it just looks like pink. It's like a bright pink. That's not purple. Okay. I feel like violet should be this last one. Whatever. All right. So we fixed it, right? It is working properly, how it should. Even though I don't like the violet. Ha. Let's go to bubble number 8. All right. On bubble 8, we have the explanation here that some conditional statements can be written as Boolean expressions and vice versa. So let's see what it looks like. First, we're going to look at this first example that they have here, starting on line 3 and going through line 12. All right, so we're going to run the code and see what happens down here in the debug console. All right, so we end up getting Boolean output of false and false. And then the last one of true is for the second part of this that we're not quite looking at yet. But let's kind of talk about this line by line here for the first example. So we have a variable y that's equal to 8, and then a variable x that is equal to y less than 6. So our console log is outputting the value of x. So x is going to be translated again to either true or false, right? Because this is a Boolean expression that it is going to determine the value of x, either being true or false. All right. So since y is 8, we know 8 is not less than 6. So that's why we get the output of false for x. All right, and then lines 7 through 12 is doing exactly the same thing. It's just putting this into a conditional statement instead of two variables being equal to something and determining whether or not that's true or false. All right, so we have the statement if y is less than 6, which we know is what x is equal to up here. But if y is less than 6, then x is going to get assigned a value of true. Else, right, if y is not less than 6, then x is going to get the value of false. All right, so again, the console log to determine what the x value is just going to give us the false value because we know y is not less than 6. So it's skipping over line 8 where it would have assigned the true value to x and going straight to line 10, which is true, right? That's the else statement, and assigning it that value of false. All right, so lines 3 through 5 and lines 7 through 12 are doing the exact same thing, just in a different way. So my class gets told there are multiple ways to skin a cat, which I think that I have mentioned that very unfortunate old-timey phrase in a past video. But all that means is that there's just multiple ways to solve the same problem with code. So your code doesn't always have to look exactly like what code.org says the solution is, exactly what I say the solution is, right? You might accomplish the same task in a little bit different of a way. So this is just 2 examples of the same task being accomplished in a slightly different way, one with a conditional, one without. All right. Then we have example 2 here. Okay, so we need to go ahead and write this as a conditional statement rather than just using variables in the one console log. All right, so it gives us the Boolean expression, right? We have a variable a is equal to 3, and then variable b is a is greater than 2. All right, and then it gives us the output of b, which evaluates to true because 3 is greater than 2. All right, so let's go ahead and just rewrite this a little block here for lines 16 through 18. Let's go ahead and write it as a conditional statement. So we know we're going to need our 2-tiered conditional, right? Because we have these values that is either going to be true or false. So those are our 2 options. All right. And we will need a console log to output the value stored in B. Okay. All right. So just like the one up here, all they've done is taken whatever they set x equal to be that Boolean expression, okay? And they put that Boolean expression in the first tier of the conditional. So y less than 6, all right? So we want to do the same thing here, all right? This conditional statement is going to be if a is greater than 2, all right? Again, you can pull in the math block. You can also just type it in. Either way, whatever works for you. All right, so if a is greater than 2, then we want to set the value of b to either true or false. All right, so we know we're going to need a variable assignment in line 20 and line 22 into both tiers of this conditional. All right, so if A is greater than 2, then B is going to equal true. But if A is not greater than 2, then B is going to equal false. All right, so we don't have to use quotation marks around them, right? Because this is just a Boolean value. All right, so it doesn't need quotation marks. It's treating it like math, essentially. All right, but this is just turning in, so lines 19 through 24 is a rewritten version of lines 16 through 18, right? It's doing exactly the same thing as lines 16 through 18. We're just putting it through a conditional instead. So now when we run the program, right, we got our false, false, and then we got a true. The true was the output of line 18, right, giving us that value of B after it evaluated the Boolean expression in line 17. All right, so now we should get true, true, which will be our output for 18 as well as our output for 24. So let's go ahead and run it. And we do get false, false, and then true, true. All right, so that is just the simple way to rewrite some code to use a conditional and incorporate that new concept into some coding. All right, so if you don't have any questions and you've got this one all figured out, we can move on to bubble number 9. All right, bubble number 9, we get to our question of can we adopt a cat? So this was an example from our flowcharts we were looking at when we first learned about conditionals in the first conditionals lesson that we had. And we are basically just transferring that flowchart into an app. So we have this user interface where we can put in what the age is, we can put in how much money we have, and then we can determine whether or not we can adopt a cat. All right. So it says that we need to add code to get the numbers the user inputs for age and money. We have these blocks called get number and get text that we are going to be using for that. All right, and we want to make sure that the values are stored as numbers and not strings. All right, and then we are going to write the Boolean expression in the if statement down here on line 13 that checks if the money is equal to 40 and the age is over 14. So we're going to need the logical operators and, or not to make this. All right, and then it just gives us the reminder that we can find the element ID of a screen element by hovering over it with the mouse. So this is our age number up here, our money number down here, which are things we are going to need to know. All right, and it also gives us the flow chart that we referenced over here on the side. So can I adopt a cat? If we have $40 and are over 14 years old, we can. All right, so we take our money and our age variables, okay? They give us the Boolean expression right here, right, using the and operator in between them. So money is equal to 40 and age is greater than 14. All right, if it's true, we can adopt our cat. If it's false, we can't adopt our cat. So let's go ahead and get this into our code. So we have our variable for age is initially set to 0, and our variable for money is also initially set to 0. We have two yellow triangles because we've defined a variable called age and we've defined a variable called money, but neither of these are called in the program yet because we need to write the code to update the values being stored in these variables. All right. So these variables are going to be updated when we click the adopt button here in the middle. All right. So we have the on event for the adopt button starting on line 4. Okay. It says it resets the images each time the adopt button is clicked. So it's hiding the yes, you can adopt a cat or the no, you can't adopt a cat images. All right. Then it says update the variables here. So it's telling us on line 9, this is where we need to update the variables. So let's go ahead and do age first. All right, and they've told us right up here in the directions what we need to do. All right, age is going to be equal to a number, okay, and it's going to be whatever number we put here in this age number text input box. All right, so our age is going to be equal to a get number instead of a get text, and it is from the age number input. Okay. All right, so that updates our age variable, and I don't know why I put an extra space there. All right, then we need to update our money variable, okay? And notice when I put age is equal to that get number, it has now disappeared the yellow triangle we had next to our line 1 variable for age because I have now called the variable in the program. Okay, the same thing's going to happen when I update our money value here. All right, so let's make money equal to our get number again, okay, because again, it's number input from this money number text box or text input box. So it's going to be our money number value. And then we just need to add our semicolon at the end. All right, and I am doing this in text mode because I can't switch to block mode, right, until we correct all of these errors. So we have these nice big red squares here. This conditional is having a lot of issues because we have not put in our Boolean expression yet or anything we need to determine this, so it's not recognizing the conditional correctly. Once we get our Boolean expression in here, we should be good to go. All right, so we have our variables updated. Now we need to write our expression so that it checks if our age is over 14 and our money equals 40. So I'm simply literally just going to look exactly at what they have up here in the flowchart they've given us, right? Our Boolean expression needs to be the same. So we have our money needs to be equal to 40. And then we use our and logical operator in between it. And our age needs to be greater than 14. Okay, so that solves the problem right there with our one line of conditional because we have the and in between them. All right, now we can switch to block mode because the errors are gone now that we have that Boolean expression in there. All right, so this is going to determine if our money is equal to 40 and our age is less than 14, then it's going to say, yes, we can adopt a cat. All right, else it's going to say, no, we can't adopt a cat. And remember with that and operator, both sides of this have to be true in order for it to give us the output that we can adopt. All right, so let's go ahead and run it and see if our conditional is working. All right, so let's just go with something that we know is going to work for us. All right, so if our age, let's say, is 15, all right, and our money is 40, right? I am over 14 and I do have $40, so I should be able to adopt a cat. All right, so it tells me, yes, I can adopt a cat. Let's put our money at, let's say, 39. All right, so now I am over 14, but I don't have enough money, so I should be told no, I can't adopt a cat with a little sad face. Oh, that kitty looks so sad about it. All right, so it is working. We can also change, if our age is 12 and our money is 39, we can't adopt a cat. If our age is 12 and our money is 40, we also can't adopt a cat. All right, our age would have to be greater than 14. So we've just tried multiple inputs here in this app to see if we could adopt a cat to make sure that conditional statement is working. And we have gotten the correct output each time. So it looks like we are good to go. All right, let's finish and go to bubble 10, which is going to be working with the same Adopt a Cat app here. All right, so we need to make a couple changes to the way this is written, it says. All right, so we need to make it so that we can adopt the cat if we have 40 or more dollars. So if I put in $41, it wouldn't have let me adopt a cat even if I was the appropriate age because right now our money is equal to 40. All right, so if I have anything over 40 or more, I should still be able to adopt the cat because if I have $50, that's enough money, right? But right as it's written right now, it's telling us that we can't adopt that cat, okay? So let's go ahead and make that change really quick. The easiest way to do that is going to be to switch back to text mode, and we're looking at line 14 where we have if money is equal to 40. All right, I want money to have to be greater than or equal to 40, right? Because if I have 40, I'm good. If I have 41, I'm good. If I have 127, I'm good, right? So our money can be any value that is 40 or above, all right? So greater than or equal to 40. So that should correct that problem. All right, and then it's telling us that we also have Teenager Day. All right, so at the animal shelter, there is a day where only teenagers are allowed to adopt cats. So we need to update the code to prevent anyone under the age of 13 or over the age of 19 from adopting a cat. All right, and it says that all of this can be written in a single Boolean expression with multiple logical operators, right? And then it gives us this chart to test our code here. All right, so let's see. We currently have if money is greater than or equal to 40, right? Nothing needs to change there, but we do need to change our age greater than 14 section. All right, we need to make sure that our age is both above, I think it was 13. Yeah. So anyone under the age of 13, so 13 or older, and then anyone who is 19 or younger can adopt a cat. Okay, so we have a very limited range of who can adopt a cat. All right, so we're going to totally get rid of this one. All right, on the other side of that and operator, but we still need it to be an and operator between our money and our age. But we also need to add in another and operator. All right, so we're going to have double ands here. All right, because for our second half of this equation, we have both above the age of 13, 13 or over, or 19 and younger. Both need to be true. So you need to be between the ages of 13 and 19 to adopt a cat on Teenager Day. All right. So we're going to have age on both sides of these, this and logical operator here. Okay. Age, we know, needs to be greater than or equal to. All right. So I'm going to pull that block in. All right. So our age needs to be greater than or equal to 13. Okay, and our age also needs to be less than or equal to 19, right? Because we cannot be 20 and adopt a cat, but we can be 19 and adopt a cat. So this should mean if I input an age from 13 to 19, I should be able to adopt a cat because both of these need to be true. All right, so that's giving me that age range there. All right, and then money greater than or equal to 40. All right. So now that we have adjusted that Boolean expression, let's go ahead and do all of these test cases. All right, so we're going to run our app. All right, so it says we are 18 years old and we have $40 for our first test case. Okay, we say yes, we can adopt a cat, right? Because 18 is between 13 and 19 and $40 is enough money. Okay, if we're still 18 and we have $50, yes, we can still adopt the cat because we have more than $40, so we have enough money and we are still a teenager. All right, then we're going to change it to age 12. Our money is still going to be 50. And this time it says, no, we can't adopt a cat, which is what we should be getting. It says you can't adopt the cat. All right, and we can't adopt the cat, not because we don't have enough money, that should be fine, but because our age is not greater than or equal to 13. So it falls outside of that parameter. Okay, and we can't adopt the cat. All right, so if we're 13, suddenly we're old enough again, right? But we only have $39. Okay, so we're going to get no, we can't adopt the cat because we don't have enough money this time. All right, and then we have $100 of money for our last test case, which is plenty of money to adopt the cat. But we are age 20, which is not considered a teenager, so we cannot adopt the cat because it is Teenager Day and we aren't one. All right, so all of our test cases are working. All right, it looks like our Boolean expression to get that age bracket in there has worked beautifully. So we can go ahead and finish on this bubble and move on to bubble number 11. I did mention that we would be exploring more about the mod operator, and here we are going to do that on bubble number 11. So remember, our mod operator is the percent sign, and it divides the first number by the second number and gives us the remainder, all right? So for our first option here, okay, we have the console log 5 mod 2. All right, and then that should, in line 3, it's telling us give us a remainder of 1, right? Because 2 can go into 5 2 times, right? 2 and 2 is 4, and then we have 1 left over. All right, so when I run this program, the first 2 lines that I get here should give me an output of 1 and 1, right? It's evaluating 5 mod 2, so that's going to result in 1. And then it's telling us the answer down here as well, which should be 1. So that's basically just verifying that the console log in line 2 did the correct thing. All right, so we get 1 and 1. And then we get an error because we don't have any numbers in our mod operator down here. Okay, so let's go ahead and take a look at this. Okay, 11 mod 2, they gave us as an example. Also is 5, right? 11 divided by 2 is 5 with a remainder of 1. So our answer is 1. All right, so it says that we are going to use each number from this list exactly once. So they give us the numbers 1, 2, 2, 2, 3, 4, 7, 10. And we are going to put a mod statement in the first console.log statement of each set to result in the same number as the second console log statement. All right, so like this first one that they gave us is the example, right? 5 mod 2 gives us a remainder of 1, and they are confirming that it is 1. All right, so using all of the numbers in the list in the comment on line 8, all right, we need to put these numbers into these empty mod expressions here to match whatever is in this matching set of the console logs. So this line 13, I need 2 numbers that will result in a remainder of 2, which is my console log output in line 14 is a 2. So whatever numbers I put in here have to be give me a remainder of 2. All right. Then, right, we have another one on line 18. Okay, that needs to be a remainder of 0. We have another one on line 23 that needs to give us a remainder of 2. And then our final one on line 28 also needs to give us a remainder of 0. So we need to organize these numbers 1, 2, 2, 2, 3, 4, 7, and 10 in a way that's going to give us either 0 or 2 as our remainder. So let's start with line 13. All right. Let's see what 2 of these numbers we can use to give us a remainder of 2. All right. So I'm going to say if I take one of these 2's that I have available to me and a 3, all right, so once I use the number, I'm going to get rid of them from the list. Okay, so I'm going to use 2 and 3 for this first one. So I'm going to get rid of the 2 and the 3 from up there to tell me what remaining numbers I have to use. All right, so if I do 2 mod 3, that should give me a remainder of 2 because 3 can't go into 2 any number of times. So we have 2 left over. All right, so we can run this after each section to make sure that we are getting those correct outputs. All right, and we have a 1 and 1 and a 2 and a 2. All right, so that one looks like it is good to go. All right, so now we need to look at this second set to give us a remainder of 0. All right, so we need something that can be divided by something else and give us a remainder of 0. All right, so let's see what we have. I know 1 mod 2 isn't going to work, okay, because 2 can't go into 1 any number of times. That would give us a remainder of 1. I can't do 2 mod 1. I could do 2 mod 1. That would give us a remainder of 0. Okay. I could also do, let's see, 10 mod 2, because I can divide 10 by 2 an even number of times and get 0. So it just kind of depends on what you want to do. Again, back to that really awful saying, multiple ways to skin a cat. So you don't have to do the same ones as me, as long as you get the correct outputs. All right, but this one, I'm just going to go ahead and use 10 and one of our other 2's here, okay? We have multiple 2's, so let's get rid of some of those. All right, so I used a 2 and I used a 10. All right, so now I have 1, 2, 4, and 7 left. So 10 mod 2, all right, 10 divided by 2 is 5, and there's nothing left over, so that should be 0. We're going to reset and run it and just make sure that, yes, we got 0 and 0 as our outputs here. All right, so when I go down to my next one, all right, now I need to get a remainder of 2 again. So my options that I have left are 1, 2, 4, and 7. All right, so let's see what we can do to get a remainder of 2. All right, with these numbers that we have left. So let's see. Weird. I don't know why that just refreshed. Okay. All right, so we have 1, 2, 4, and 7. So let's see. If I took 1 mod 2, all right, that's going to give me a remainder of 1. So that's not going to work. If I did 1 mod 4, that gives me a remainder of 1. And 1 mod 7, same thing. That's always going to give me a remainder of 1. Okay? If I reversed it, let's see if we did 7 mod 1. That's going to give me a remainder of 0. But I want a remainder of 2, so that's not going to work. All right, 4 mod 1 gives me a remainder of 0. And 2 mod 1 gives me a remainder of 0. So I don't think we can use the 1 for this. And I also don't think we can use the 7 because that's an odd number. And everything other than the 1 are even numbers. So that's probably going to give me an odd number left over, right? Because if I did 7 mod 2, that would give me a 1 left over. And then if I did 7 mod 4, that would give me a 3 left over. So that's not what I want. If I did, let's see, 4 mod 2, that would be a remainder of 0. That's not what we want. But if I did 2 mod 4, right, 4 can't go into 2 any number of times, so we are left with our 2. All right, so that one would work to give us a remainder of 2. 2 mod 4. All right, so that gives us a remainder of 2. All right, let's get rid of both of those numbers, and we're going to run it just to see. All right, and in our debug console down here, we did get 2 and 2. All right, so we are good to go there. All right, and then we're left with 1 and 7. All right, so we know those are the only 2 numbers we have left to use. All right, and we need a remainder of 0. Okay, we know that 1 can go into all of the numbers as many times as it needs to, and we're not going to have anything left over because we're just taking 1 out every time. All right, so 7 mod 1 should get us a remainder of 0 because 1 can go into 7 times and we won't have anything left over. All right, so when we run it, our final output then becomes 0, 0. Okay, so all we were doing was figuring out what the remainder of the combinations of numbers were for these, right? And then making sure that it matched the remainder that we were trying to be left with for each of these. All right. Again, multiple ways to do this. Just because I have 7 mod 1, 2 mod 4, 10 mod 2, and 2 mod 3 doesn't mean that you need to have those. As long as you can combine these numbers in a way that gives you the correct outputs, you've done it correctly. All right, so let's go ahead and finish bubble 11, and we will move on to bubble number 12. But really we won't, right? Because 12 is our practice bubbles here with our A, B, and C. So per usual with my class, you guys are on your own to work through the Chronotype app, the music genre quiz, and the Fizz Buzz app. And you are going to finish the code and make all of these things work. And those of you that are just watching these videos and not in my class, we will cover 12A, B, and C in the next video. So I'll see you guys then.